That means 65% of verifiable entities in the outputs were not surfaced as named subjects by any extraction method tested. That is not a measurement of how often AI systems hallucinate. It is a measurement of how often the verification pipeline could even find a claim to check. The Te Pono V.E.R.A logic engine introduces claim_extractor.py. This episode version 0.1.04 documented failure modes, and one working baseline when FFACT 0.35. That is where the pipeline stands. If your organization is relying on AI output in a regulated process, which of the 4 failure modes in this episode does your current verification approach already handle? V.E.R.A Saturday, the Hamberger report, link in bio.
Let's get into it.
In 1992, a Finnish student posted a kernel to Usenet. Nobody wrote the pipeline to verify what the kernel claimed. This is the Hamberger report. I am Andreas Hamberger, Enterprise Architect, Wellington. 3 episodes ago, the Te Pono V.E.R.A logic engine had a structural problem. The Krempitz analyzer could classify non-traditional predication theory formulas. The formula parser could convert natural language into those formulas, but the pipeline had no module that could look at raw unstructured AI output and decide which sentences contained claims or what those claims were about. Claim supply was manual. That ends today. Episode 21 introduces claim_extractor.py, version 0.1.0. It runs, it produces output, it fails in 4 specific documented ways. Mean fact score across 5 simple tool HoloBench calibration cases is 0.35. That is not a success story. It is a starting point with an honest measurement. Arc 3 recap. Episode 18 showed that latent space opacity removes the internal reasoning trace. Episode 19 showed adversarial training degrades tool reliability. Episode 20 confirmed the United States Frontier AI Executive Order of 2 June 2026 endorses external referent verification. The architecture was described. The open problem was named. Today, code addresses it. A language model produces output. Some of that output asserts that things exist. Each of those assertions is an existence claim. The pipeline needs to know which sentences contain them. In non-traditional predication theory, these are E-type claims. They presuppose the existence of their subjects. The V.E.R.A E! verification service can look up those subjects against external reference. But first, the pipeline must surface the subjects from unstructured text. Longbear. The aircraft type is a Boeing 737 MAX 9, is an existence claim about a specific airframe on a specific route. This appears consistent with recent data, is not an existence claim at all. The extractor has to distinguish between them across tool call outputs, search results, and free-form reasoning passages. The skip filter handles hedged, conditional, and opinion-bearing sentences. Sentences containing modal verbs, conditionals, or explicit uncertainty markers, route to the N-type path, and bypass E! lookup. The conservative default is correct. If the filter is uncertain, the sentence proceeds to pattern matching. A mischeck is a gap in coverage, not an asserted falsehood. The claim extraction module is Python, version 0.1.0. It ships as claim_extractor.py alongside the Krempitz analyzer and formula parser in the open V.E.R.A repository. The core extraction logic works as follows. The claim_extractor.extract method receives a text string, splits it into sentences, and runs each sentence through a skip filter before pattern matching. 6 pattern categories cover the common structures in large language model tool call output: copular assertions, possession statements, founding claims, functional claims, numerical claims, and relational claims. A 7th category handles JSON key value fragments directly. All extracted claims are flagged as requiring E! verification by default. The N-type bypass is assigned only when the skip filter identifies a sentence as hedged or opinion-bearing. If in doubt, verify. The 6 pattern types map to NTP predication structures under Wessel's Krempitz rule R1. The claim extractor segments unstructured text into units. The Crumpets analyzer can formalize. That is the correct division of labor at version 0.1. The Lethal by Design series, running Fridays on this channel, examines the accountability gap built into military AI systems. If you are following both arcs, subscribe so you have both when episode 6 arrives on 31st July. Back to calibration. Simple Tool HoloBench provides structured tool call outputs with ground truth entity verification. 5 cases were run, 4 ground truth pass and 1 ground truth fail, containing a fabricated flight number and aircraft type. Mean FFACT score across the 5 cases is 0.35. FFACT measures the fraction of ground truth exists entities that the extractor successfully surfaces as named subjects. A score of 1.0 means every verifiable entity was extracted. 0.35 means 65% of verifiable entities were missed across these 5 cases. The FAAL case, STH003, the extractor surfaces Air New Zealand and the aircraft type. Air New Zealand routes correctly to E! lookup. The aircraft type routes there too, but Boeing 737 MAX 9 does not appear as a named subject. The hallucination is not invisible to the pipeline, it is incompletely named. That is FM01. 4 failure modes. None produce hallucinations in the extractor itself. They produce missed coverage, claims that go unverified because the extractor did not surface them. The pipeline remains safe, its recall is limited. FM01 is implicit subject. The aircraft type is a Boeing 737 MAX 9 extracts. The aircraft type, rather than Boeing 737 MAX 9, E! lookup, on the aircraft type, returns unknown. Resolving FM01 requires co-reference resolution, tracking that the aircraft type in sentence 3 was named in sentence 1. That is a separate module, not yet in scope. FM02 is pronoun co-reference. Pronouns are skipped. Recall loss is real. No false positive is introduced. FM03 is coordinate subjects. Only the first subject may be extracted from a compound sentence. FM04 is named entity boundary. Multi-token proper nouns may be truncated. This class of infrastructure is becoming a sovereignty question. The United Kingdom Ministry of Defense JSP 936 framework requires verification evidence, not vendor attestation. What JSP 936 requires as process. V.E.R.A builds as code, a machine-readable audit trail from raw output to verified claim. States that can produce this evidence on demand and those that cannot occupy measurably different positions in procurement accountability. FFACT 0.35 is the beginning of that infrastructure. The pipeline now has 3 components with running code: the Crumpets analyzer, the formula parser, and the claim extraction module. The E! verification service has an architecture and a target external referent, the Wikidata application programming interface. Episode 22 will show the first end-to-end run, the flight search case from Simple Tool HoloBench. STH003 is the primary test. Air New Zealand should return exists from Wikidata. Auckland should return exists. Sydney should return exists. The flight number claim should return unknown because no verified source confirms flight NZ289 on that route. Improving extraction recall is the parallel version 0.2 task. FM01 is highest priority. Implicit subjects are the mechanism by which hallucinated entities most readily escape surface extraction. FM04 is second. Multi-token proper nouns are among the most common subjects in tool call outputs. Both are in the repository as open issues. The repository is at github.com/Andreas-Linux/V.E.R.A. If you work in natural language processing, named entity recognition, or co-reference resolution, the open issues are the engineering contribution pathway. 3 pipeline components with running code, 4 documented failure modes, 1 calibration baseline, FFACT 0.35 on 5, Simple Tool HoloBench cases. That is where the V.E.R.A logic engine stands today. The V.E.R.A logic engine is built on a logical foundation from 1992. The engineering is built in 2026. Both are open source under GPL 3. V.E.R.A Saturday on the Hamburger Report. Link in bio to the series in the repository. Episode 22 brings the end-to-end run. The code is running, the measurement is honest, the work continues.
That is the Hamburger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
Like and subscribe.